Yeah, welcome once again. And so participants are less today. I don't know. Maybe because of the break we had. I think there is a decline the people joining it. But yeah, let's see. So oh, my screen is not visible here. I'm audible, yeah, clearly. I think so.
Yes, ma'am.
Yeah, thanks. So yeah, welcome all. And so today we are, so this is the course of, the name of the course is Research Methodology in Natural Sciences, and this is the week 6 discussion. So week 5 discussion is something that we missed, but essentially I thought to keep the pace, to keep with pace with your assignments, we shall discuss with week 6. Maybe in meantime, in between, maybe in some time I will find a time, and the NPTEL will, team will send you the notification, then we can cover up with the week 5 also. Essentially, today we will be discussing with the week 6 only. So I am Udipya, and I am a PhD scholar from IIT Madras. So, yeah. So this week we saw three important things, um, namely the central limit theorem and its applications, error bars and the confidence interval, and the measurement of proportion. So we will see. So we will see them once one at a time. And the, the structure that I follow usually, whoever is attending will know that mostly we discuss the first the theory part of it, and then maybe half an hour, and then 1 hour we will discuss the questions, some problem examples, and then half an hour is kind of we discuss some of the doubts or any discussions, kind of how to improve the sessions and so on. So that's like that. So before discussing the different central limit theorem and error, I wanted to discuss what is a sample and population. So uh, anybody would like to tell what is the difference between the sample and a population? Then maybe we can discuss it. So maybe I will stop the video for once, because some of you may have low bandwidth. Anybody? So people can write in the chat, and also unmute yourself and tell. So the difference between actually the sample and the population. So we will use these two terms a lot, that's why. Okay. No one, I suppose. Then we'll go. So a statistical population is the collection of all possible observations of a specified characteristic of interest. So all the possible observations is known as a statistical population. And a subset of population observations taken for the purpose of obtaining information about the population characteristic is called a sample. So population is all possible observations, and this is the subset of population observations to obtain the population characteristic. So sample. So if we are not able to take all the observations from a population, we try to take a smaller subset, which is called as a sample, and then try to understand the population. So because in most of the instances, taking all the observations about a population is very difficult. So we tend to take a smaller data set. That's a sample. So statistical methods are used for drawing conclusions about the sample, about the population by means of data collected from the sample. So uh, because taking the population is way harder than taking the sample. So we take it and then we obtain the conclusions from the data collected from the samples about the population. So in a company, the entire collection of numbers representing the ages of different employees constitutes the population. So all the employees in a company, their ages is something that's the population. So each number of population is called an observation. So each and every case is observation, and then the employees who are observed are elementary units of the population. So any finite collection containing the part of observations is called a sample. So it's kind of repetitive, but yeah, that's what is making it to make it evident actually. So the number of units or observations, so is in a sample is called the sample size. Okay. Anybody has any doubts or any clarifications? Okay. Well and good. So okay, I had another point. A sample is a part of a population which is studied not for its own sake, but for making a generalization or drawing inference regarding the characteristics of the population. So yeah, so basically the application of sampling essentially to draw inference, because we can't go with the whole population. So all the slides will be there in the drive, so you can maybe take it up once again. I submitted there. So yeah. So if the characteristic of interest, that is observation in the population, are expressed numerically, such as weight, height, income, etc., then the population is called quantitative. Quite simple, yeah. And if the characteristics is of qualitative nature, is a qualities such as marital status, occupation, sex, etc., then the population is called qualitative. So, and out of these qualities, then a statistics comes. Yeah, the statistic is a statistical measure based on all the units selected in the sample. Example, sample mean. Then we have sample standard deviation, proportion of defects, etc. So yeah, there is something as a population mean, and then there is also a sample mean. Sample means only from the sample, the information derived from only from the sample. That's the difference between sample mean and the population mean. Okay, I think it's clear till now. Okay. Then comes a parameter. A parameter is a statistical measure based on all units in the population. It defines a true characteristic of the total population. So when you measure it statistically on the whole population, we call it a parameter. So the terms like mean, median, mode, variance are called parameters when they describe the characteristics of the population, and are called statistic when they describe the characteristics of the sample. So this is the difference between the parameter and the statistic. So when they are of the whole population, we tend to call them as parameters, because they essentially tell the story of the population, whole population. And we call them statistic when they are when they are derived from the sample, which is a subset of the population. Yeah, please. Yeah, Smriti, you want to ask something? You can unmute or write in the chat.
No, sir, it was just a mistake.
Oh,
Sorry.
sure, sure, sure. No issue, no issue. Yeah, sure. So anybody has any doubts, they can just ping me in between. It's not an issue. So yeah, everything is okay. Then we come to sampling error. So these are we understood what is samples and population and the application of sampling. Then a sampling error is the difference between the actual population parameter and the sample statistic. So now there comes what is the error. Because we are essentially selecting a subset, and then there can be a difference between the whole population and the basically the parameters which is of the whole population and of the statistic which is derived from the sample. So there would be a difference in the value. So that what is a sampling error. So a large sample contains 25 or more observations. Some books will tell it as 25, some books will tell it as 30. So it's kind of in that region actually. Yes, I do believe there is no like strict boundary, but yeah, people usually tend to tell it around 25 to 30. So the samples containing less than 25 observations are called as small sample. So in some terms, the small sample and big sample is coming because we will see it how it actually makes sense. Because when you have a large sample, the sample statistic and the sample parameter, how the sample error essentially behaves in cases of large sample and small sample is something that will make it sense that how it is important. So the number of observations that we discussed, the number of observations contained in the sample is called a sample size. So the standard deviation of the sampling distribution of the statistics is the standard error of the statistic. So we will also see how to calculate the standard error. So we'll see that. And then it is used for test of hypothesis or test of significance. So these are essentially some of the important tests, and we have some numericals that essentially describes how this test of hypothesis and test of significance will do. And so I don't think so these are included in this one perfectly, but yeah, in the other ones in the coming chapters we will get to see it. Then yeah, the standard error gives an idea about the reliability and precision of the sample. So yeah, how much, so because if the error is very large, then it's not reliable. So we have to see how it is varying from the actual population. So if it is not reliable, it is varying too much, then it's not reliable. Then standard error is used to determine the limits, confidence limits or interval estimates within which the parameter is expected to lie. So we have some numericals telling us that. So the standard error of mean is written as this one, sigma x bar is equal to population standard deviation divided by the square root of the sample size n. So we'll see it. So this one, yeah. So sigma, this is the sigma of the population, and this is the sample size. Okay, so that's what is a standard error of a mean. Okay, anybody has doubts in this formula? Okay, so if n is equal to 1, standard error is equal to the sigma. Yeah, that is if sample. Yeah, please, Vani, you wanted. Vani, you want to tell something? Okay, so it's evident, yeah, if the sample contains only one unit, then the standard error will be same as the standard deviation of the sample. So as n increases, as n will increase, the standard basically we have to, I had missed this one, decreases. When the sample is large, the precision is more, therefore for better precision. So if you have more higher sample size, the standard error it will decrease. That's what is it. I just forgot to add this. So large sample provides a more reliable estimate of the population mean for the same level of precision. In other words, smaller the value of, the more accurate will be the sample result. So we essentially want this value to be smaller, yeah, then the error will be smaller. To make it smaller, what we have to do is we have to increase the sample size. So sample size is, because it's in the root, and so if we increase this will come down. Both are inversely proportional. So the accuracy of the sample results depends not only on the sample size. Somebody would like to speak or what? I'm not getting it. I'm not able to hear actually. If you want to speak up, you can. Otherwise, you can write in the chat maybe. Okay. Anyway, moving on. So the also on the standard deviation of the population. So so basically standard deviation also plays a role in determining the standard error of the sample. So the sample error is mean of the single gauge of a sample accuracy that incorporates the effects of both the size of the sample and variability of the population. So these two things are incorporated in the in the sample error. So both comes together and tells us what is the sample error. Okay. Any doubts?
Hello.
Yeah, please.
Yeah, Madhura here.
Okay.
Yeah, as said that standard deviation will be of the population.
Mm-hmm.
If you don't have any known value for this,
Mm-hmm.
is there any other formula to calculate the standard error?
See, if we are not getting the standard deviation of the sample of the population, then we will go with the standard deviation of the sample.
Standard deviation of the sample. Okay.
Yeah. Yeah.
Can we move with the degree of freedoms as well? No.
No. Can you explain it by the graph? Okay. Once it comes to the central limit, we can actually, but these terms are actually difficult to. These are more of the quantitative nature actually. Graphically, I'm unclear on how to show them. So once the standard it comes from the central limit, that's the way how we describe it in graphically. So I will show it in a few slides actually. Okay. Madhura, am I did I answer it or?
Yes. It was clear. Thank you.
Sure. Okay, thanks. So yeah, for a given population, the standard deviation is fixed. So it comes from this, and but the standard error. So this slide tells us the difference between the standard deviation and the sample error. The standard error is this one. The sample error. Okay. So when the sample size increases, standard error decreases because sigma is fixed. So when the sample is large, each sample mean becomes close to the population mean, and the deviations of the sample means from the population mean become very small. So the deviations are less because the standard error is less. So yeah, that's that's what is repeated in the last sentence also. So essentially, more number of samples is always beneficial. That's what is the kind of a uh, like take away statement, kind of take home statement maybe. Yeah. So here comes the central limit theorem. So normal distribution is one of the crucial part of central limit theorem. So can anybody tell what is this, like any terms or like any idea about the normal distribution? So normal distribution is something quite like foreign to you all, or then maybe I can explain once. That's why. Anybody would like to tell what is standard? What is a normal distribution? No. Okay.
Graphically, which has a bell-shaped curve.
Okay.
Yeah.
Okay. Then. So its center lies at so it is symmetrical about so it's actually it is symmetrical about its mean. Okay, nu, that we like denote it as a mean, and its dispersion is determined with the standard deviation. So two parameters are actually important uh, in um, uh, in understanding a normal distribution. Is uh, one is the basically the mean, and another is the standard deviation. Okay, so whatever is the I forgot the term. I forgot what is the distribution around but 1 sigma, but essentially the number of populations which will be there in each of the standard deviation is something that is defined actually. Okay, so this is 1 sigma maybe, then this will be 2 sigma. So that is kind of tells us the dispersion of the graph. Okay, it essentially there is a law actually.
Confidence interval.
Yeah, confidence interval also.
3 sigma rule.
Yeah. Okay, I will come back to it. But essentially, this is so basically the graph is symmetrical about its mean and the dispersion of that graph. So how much skew it will be, or how much. So this thing and this thing will be determined by the standard deviation of the data. So that's what is the core of normal distribution. And can anybody comment on the mean, mode, or median of the standard of normal distribution?
All are same.
All are same, and yeah, all are same actually. Yeah. So that's makes it a like kind of a unique. So these are some properties maybe. So yeah. So I didn't make a dedicated slide actually, but yeah, I thought okay. Anyway, coming to the central limit, it is so central limit theorem essentially is valid mostly when the sample is large, that is then it crosses the number of 25. The above statement of central limit theorem is true regardless of the shape of the distribution of the individual values in the population. So your population can have a different kind of distribution, yeah, Poisson distribution or other kind of distribution, but it is valid when you are making the sampling. It is valid that you if you have a more than 25, this central limit theorem is valid to it. And if the distribution is known to be approximately normal, and then you can apply central limit theorem to lower smaller size samples also, like less than 25 also. So that's what it is. Okay. So so basically standard area indicates the fluctuation of sample means around the population mean. Okay. Then we have P is the proportion of defectives in a random size n drawn from a population of defective P naught. Then the sampling distribution of the sample proportion of the defectives P is approximately a normal distribution with the mean P naught and standard deviation equal to standard error out of P. So essentially that how much defects we are telling is we will find the probability of it. So that I will show you in the next slide essentially.
But if the hello.
Yeah, please.
If the sample size is less than 25, that is maybe
Uh-huh.
20, limit will not apply.
So basically then it essentially comes down whether the distribution to the distribution actually. So if it is approximately normal, it works most of the time, but if it's not, then there is a issue actually.
In order to get it applied, we must have the sample size equal to 25 or more than 25.
Yeah, equal to or more than 25 is good.
Okay.
Rajeshri, you want to tell anything?
When sample size is than 25, we apply T distribution.
When the
Student T distribution.
yeah, there are some other tests also, but essentially I think those are included in the next parts. Yeah. Okay. So yeah, we will see the maybe the other use cases also. Yeah.
Okay.
But essentially you can also apply this. So yeah, this also is a good to go.
Hello.
Yeah, Madhura, please.
If possible, can you state a practical application of central limit theorem other than stating for the confidence intervals? Means it is being used to calculate those kind of things, but any example with a practical application?
So it's so practical application in a sense. It's like you have a class. Yeah, in a class you have students of different heights. Yeah, then we plot them. So in the median, so there will be people who are extreme short. Then there will be people of extreme height. Then there are people who are kind of median, the Indian height of people are. So there you may find it more people are in that region. So this is this will essentially form this kind of a bell-shaped curve, a normal distribution.
Yeah.
So if you are not taking the whole class, you take around, so you have a class of 100 students, then you take around 25 students. So you should be able to see the same kind of distribution. If not perfectly the mean will match or not, but you will see kind of a same kind of distribution there also. So that's kind of a sampling from a whole class.
Okay. Okay. Thank you.
Yeah, sure. Okay. Should I move ahead or?
Yes, it was clear. Thank you.
Yeah, sure. Please. Okay, thanks. So yeah, so in standard normal distribution, the standard normal variate z is defined as z equal to x minus nu by sigma. So x is the value that we'll see from how far it is from the mean. So we will see the use cases here. So essentially, so if it's so this is the curve, and we have nu here, and we want to see the value here, which is which is x actually. So how much population will be there? We can see this. So essentially this has how much area and this has how much area. So the area under the whole curve is yeah, perfect. So there will be 0.5 and here will be 0.5. Then we can calculate how much is less than this x value or more than the this value. So for that we have this normal variate. So for large samples, the sampling distribution is normal distribution. The normal variate is defined as standard normal distribution, mean equal to 0. So uh, we will take it as 0, and this is minus point till minus 0.5, and this is 0 point plus 0.5. So we will minus it and then take it as this is the origin. Okay. So the total area under the standard normal curve is taken as 1. So as the normal curve is symmetrical about the mean, half of the area is on the right of the mean and the half on the left of the mean that we discussed here. So for large samples, sampling distribution is normal distribution. The normal variate is this one. Okay.
Actually, it is a normal distribution curve.
Yeah, this is a normal distribution curve. So yeah, for so as it tells, yeah, the sampling distribution for large samples is normal distribution. Okay, so this z can be positive or negative, and so it can be positive this side also, this side also, and the new the sample the mean that can that will new the mean will lie between uh, the x so this is the mean from the z, so that's the z value, the z variate, plus and minus. Okay, so we'll see the use cases. Maybe with the sums it becomes because too much theory is kind of quite cloggy. So yeah, we'll come to the problem then. Okay, so before problem, any doubts, or should we directly go? Okay, so this is a sample. So it is kind of a continuous question. So yeah, so there are 25 samples taken from different parts of a liquid and I have obtained the following data. So we have concentration of a substance. So concentration of a substance, essentially, if you have so it can vary, yeah, depend on the different parts of the liquid it is, because like obviously it is like kind of we are mixing it, but it's not always that every part will have the same concentration. Essentially, if it is not kept for very long periods or so, or then it becomes kind of equilibrium. But yeah, then also it has quite differences. So these are some of the values which are in ppm, parts per million, and yeah, so we have to calculate the mean. Please write the numbers. Actually, we need it for the next questions also. So as I was telling, I just took it up from the book actually, that one standard deviation will have 68% of the data of the population or sample, and then it has 2 sigma, it has 95%, and 3 sigma, it's 99.7%. Okay. Not related to the question anyway, but yeah, just okay. Everyone is getting it, yeah?
Sir, what exactly does the word sigma mean?
Standard deviation.
Okay, sir.
Okay, everyone got it, yeah? Everyone is trying. Okay, so yeah, so the basically the formula is to add all the figures, so 4.87 plus 5.08, 5.06 divided by 2025. So it's around 5.0184. Yeah, most of you have gotten that. So anybody has any doubts in this? So it's the total observations by the number of observations. Okay. So we'll go ahead. So now we have to find the error bar plus minus. So it's the standard error. So I hope you had the data. If not, then I can show it again.
You mean to set the mean, sir? The mean value?
Hmm?
The data you are expecting is the mean value?
No, you have to find the standard error.
Okay.
Sure. I will show. Yeah, error on graph. Yeah. Okay. So as I told, though we have this uh, kind of a distribution in normal, yeah. Then the standard deviation, one standard deviation. So standard deviation will have some value, yeah. It will be plus minus something. So taking it like this, we will have um, around what percentage? Uh, what was it? 68% data in this area. The standard error is essentially divided by the standard. So we have standard deviation is kind of this. Then we have the standard error, which is the standard by n, the number of samples. Yeah. So That's the plus minus, the standard error actually. That's what it is.
Please tell us how to calculate this, sir.
Hmm?
Please tell us how to calculate the error bar.
Okay. So first step would be to find the standard deviation. So standard deviation is sigma square is equal to this is the variance obviously. Sigma square is called it as a variance. Okay. Then we will put it sigma and then the standard deviation comes out around 0.15. Okay. Yeah. Then as I told this the standard error is sigma upon the number of samples. That's how we get 0.031. So yeah, some of you are getting it like that. Okay, it makes sense now. Yeah. Okay. So so now we have to state the range in which the true value of the concentration must lie with the 95% probability. So okay, so I have to look at the z value at 95% probability. Z value at 95% probability is 1.96. Okay, so yeah. Okay, to decide, divide by n minus 1, right? Yeah, so actually, the thing is, when we are working with population, we don't divide by n. We actually divide by the n itself. Mostly we are working when sample. We divide by n minus 1. So I don't know what I used. I think I divide by n. So there is some kind of correction factor actually involved here. So so yeah, I think here also I have to I think, yeah, then I have to add 25 minus 1. So yeah, then whatever you are getting will be correct. There's some correction factor actually involved in it. Thanks. So yeah, the value will come like this, n minus 1. Different answer. So anybody else who is getting, so anybody has range 4.95 to 5.08. Okay.
Sir, please explain this point again.
Huh?
Please explain this again.
Okay, sure. So the what it is, the z value is there, plus minus z is equal to the x minus nu, the standard error. So plus minus z equal to 1.96. Yeah, then x okay, and sorry. So yeah, 1.96 into standard error is 0.031 and nu. Yeah, that's the x. So this will be the range. So we don't need the plus minus value. Yeah, just we need the okay, maybe the plus minus value also will include. So 5.0184 plus minus, I have to calculate it. One 1.96 into 0.03 plus minus 0.76. Yeah, so that will be the value. It's everyone is getting it. So actually it's like, if you have, huh? Yeah, please.
Please explain again.
I'm not getting it.
How is that 0.84 plus minus and this 0.027 is equal to?
Okay. What thing? I am not getting it actually. The voice is kind of cracking, maybe from my side or your side, I don't know. Can you write it? Yeah, that will be better, I think. Okay, maybe you write it. We can discuss it once again. Also, no issue. For some reason, I'm not able to hear actually. So now we have to find with what confidence level can you state that the actual value lies in the range of 5 ppm to 5.036 ppm. So I, uh, I suppose that you have those Z tables in your disposal. So otherwise you can maybe just search in Google Z table. Yeah, it will be available. So it's what was it? Yeah, this is the mean. Yeah, it's 0 actually. So now we have to find out 95% probability like what should be the confidence level that it essentially lies in this given ranges 5 ppm to 5.036 ppm. So I hope you all are doing it here. So essentially we need two Z values, and then you have to see how much area is under that curve. Okay. Okay, Abhishek, maybe you can unmute and tell, like for 5 ppm, how much you are getting Z, or like what's the approach you are doing? Abhishek, I hope I am audible. Yeah, you want to tell like how you are doing it also? Okay. So others are also getting it, or? Nope. Okay. So essentially, so there will be this is the mean, yeah, and then we need something, so we can consider this as z1 and this is z2. So z1 may correspond into 5 ppm and this will be z2 will be 5.036. So essentially because it's it is more than the mean, which is 5.0184. So first we will find out what is the so basically we need what is this area. That's our question essentially. So we find the z1, which is 5 minus 5.0184 divided by 0.31. This is the standard error, yeah. So what you are getting it here? Something negative, yeah. Minus 0.57, okay. Okay. So this is the z, this value 0.57. Okay. So you calculated the area under this, like from 0 to this. From that z table, yeah.
So how new value will be there? Mu equals to 5.
We calculated that actually in the first part, first question. So the standard error and the new we are. So this is a continuation kind of. Okay, z value is 0.1, like the area under this, yeah, or what? Okay. So essentially, so I think you are telling the whole area kind of from not the half, yeah, the area under. So basically, I think you are telling this one. If it's 0.57,
Excuse me, sir.
the area like this. Yeah, please.
Sir, just wanted to ask you one question.
Sure.
Sir, what will be the weightage of such questions in the exams?
That I'm unclear. So yeah, there will be some numericals, I hope so, but yeah, but that's not a major kind of, only 1 or 2 chapters I think is on numericals.
Okay. Because for me, this mathematical problems are a bit difficult. That's why I
Got
just
it.
wanted to know what will be the weightage of such questions in the paper.
Yeah, got it. Yeah,
Don't
it will not be much actually. Yeah.
alone in that. I am also in the same boat. And all these questions I am solving, but it's German and Greek for me.
Okay. Yeah.
I am basically a doctor, sir.
Okay. Okay.
Mathematics, it's a bit tough for me.
So the same case.
Actually, I have. So in the coming slides, I have some questions that are maybe pertaining to medical. So yeah, just you can maybe see it. Maybe you can have a feel of it.
Sure,
Make it more personal. Yeah.
Let's move forward.
Studying in the same school. Everybody studying in the same room.
Okay. Yeah, I will try to make it more graphical or something. So basically, this is a Z1, Z1 or Z the pertaining to the 5 ppm. So we need to find this area. So that what we have to find from the Z table. So if you have a Z table in front of you, you will have Z, and here you will have this value, yeah, 0.5, 0.1, 0.2 and all these things, and here we'll have other decimals, 0.00, 0.1, yeah. Okay, Z value at 0.57 minus 0.57 is 0.1. Okay, you will get these values, yeah. I hope so. If you have the Z table in front of you, I think everyone can follow it, yeah. Okay, so you have to see what's the value at 0.57. So you will have 5 this side, and then maybe from the decimal point get 0.57. So what will be the will be the that will basically say the area under the curve. Okay, so so there in most of the graphs it can be, so this is the standard deviation, this is the normal distribution. Most of them can tell the area which is like kind of from the whole, and some graphs will tell from the only from the this part, like from the zero. Some can say like from the whole, and some can say from like this. So you will have that in the top of it, top of the table, basically what area it is telling. So if you have this kind of thing, then essentially if you have the value, if you want only this one, so you have to minus 0.5 or minus 0.5 from it, because this area is 0.5. So this area is 0.5 and this area is 0.5. So that's the thing. So Rajeshri is writing that Z at 0.7157 is this one, and minus is, yeah. So essentially the area remains the same, yeah. If you have this in this is 0.57 and this is 0.57, it doesn't matter actually, because this is symmetrical curve. So the area that is from the zero remains the same. So you have two kinds of graphs, two kind of Z tables there. Just see whatever Z table you have, and each Z table will tell you that value. So I'm going with their value only. So if it tells that area from 0 to Z1 zone is equal to 0.2843. Okay, so Z2 also we can write. So Z2 will be somewhere in this area, okay, pertaining to 5.036 ppm. So we will calculate it as 5.036 minus 5.0184 divided by the standard error. Okay, some value we'll get. I don't know how much we are getting here. 0.55. Okay. 0.57. Okay. Oh, whatever. I don't know, whatever it come. Should I calculate? Yeah. Okay. I don't have a calculator, but 5.03 minus
0.37.
37. 37 is I don't think so. For me it's coming 0.57. I don't know. I'll take 0.57, yeah. So okay, so now we have to find the area that is in this region from 0 to Z5, Z5 point, like Z2 essentially. So what to do? So just look it in the so essentially it's kind of double of it, yeah. So this is also 0.57 and that is also 0.57. So we can essentially double this value. So because essentially this will be same. These are kind of 0.57 and 0.57. So we can, because these graphs are symmetrical, we can take it as the area will be 0.2843 into 2. So that will tell us what is the area that is under Z1 and Z2. What is coming? No, the double, yeah, it's coming like that.
It's just 0.56. 0.5686.
Okay, yeah. So basically 56% of the data will lie with 56% confidence it will lie in that region. That's the essentially the meaning of it. So should I move ahead?
Yes, sir.
Thanks. Anybody has any doubts, we can discuss it, no issue with that. Maybe in the last half an hour also, then we can take it. Whatever the issue is, kind of, we can take it. So a scientist could take only 10 measurements on the molecular weight of a new compound, and the measured values are this. So we have to tell, do the data provide sufficient evidence to say that the compound's molecular weight is less than 58.5? So here the sufficient evidence implies that the probability that the statement is wrong is less than 1%. So this question is not related to the previous one, yeah, just to clarify. This is a new question, kind of. Okay, in last question, you got 2 into 0.7157. Okay, so yeah, so essentially it will come, I didn't calculate the Z value maybe. Okay, maybe you can look it up next time. But like in the last half an hour, I actually took, uh, like I followed whatever Z value you had told actually.
Actually, Z value indicates area to the left,
Okay, yeah.
where
So,
we should subtract 0.5.
yeah.
So, in order to get the desired result,
Yeah,
That's
those, yeah, that matters actually. What kind of table you are seeing. So yeah, depending on it, you have to essentially. I didn't had a Z table in front of me actually, so we can discuss that. But the basically the flow or the method remains the same actually. The values may change. So first we have to calculate the mean maybe here in the standard error and then go ahead with it.
Error delay.
Huh?
Error.
What I am not I don't know, your voice is kind of today not audible. Yeah, the last question, the Z values, the Z values were different. Yeah, the Z values were I think misinterpreted. Yeah, the answer would come around 43.7. Yeah, around that 43.7. Okay. What is the mean here?
56.9. 56.9.
50, 56.9.
9.
Okay, so let me see. Last time after
56.9.
last, huh? Yeah, just let me see once. The last time also I took it. Uh, for me, it's coming 56.75. Yeah, this is a mean. And standard error. This is 0. Okay, that's difficult. Anybody else getting a standard error? Nobody?
Getting the standard area, so we need to calculate for standard deviation.
Standard deviation, yeah.
Then we have to apply that standard area formula is equal to
Yeah, we have to divide
basically
it by root 10.
yeah, root 10, yeah.
Standard error, others are calculating it. 7.41. Don't know. I have to calculate. Okay. So I don't know, I am getting it around 0.51. Uh, so if you are able to get these two values, is it? Okay, just give me a sec. I will also calculate 1 second. Yeah, I'm also getting around standard deviation around 1.53, and then we have to divide it by root 10. Yeah, so root 10. Yeah, I don't have a proper calculator actually. So yeah, just divide 1.53 divided by root 10. Whatever comes is a standard error. Mm-mm. After dividing by standard error, because I'm not like, I don't have a scientific calculator actually. That's why. 0.48. Okay. Okay. Yeah. So now we will take z. So this is the z. We'll calculate x minus nu by standard error. So you have x is this one 58.5. So 58.5 pertaining to 51.8.5 minus the mean 56.75 divided by the standard error. So what is the z we are getting? This I can calculate in my calculator also.
.64.
Okay, 3.64. So can anybody look it up in the z table? acceptable. Somebody is looking at you. So we need to see if this is less than 1% in this region. Okay. So is this region less than 1%? So this 0.9986 is essentially this area, yeah? Not this area, the one. The answer will be yes or no. That's the question. 58.5 came. 58.5 came from the question actually. It was the question that whether it will be the value we will take, will it be less than 58.5 or not? So the question tells us that do the data provide sufficient evidence to say that the compound's molecular weight is less than 58.5. So that's where it came from. Sure. So answer is yes or no?
Yes, it's less than 1%.
Yeah. So basically this area will be less than 1%. Yeah. That's what tell it is less than. So sufficiently the molecular weight of the compound will be less than 58.5. That we are safe to say. That's what the data says. Yeah. So yeah, I don't know how it took. That's how I got 5.51. But yeah. Okay, I will not go into the calculations maybe, yeah. But now I don't have a calculator actually, so that's the issue. Anyway, the steps remains the same actually. So one maybe little less numerical, but yeah, it involves numerical, but yeah, just one question. It's kind of a theoretical, or not a theoretical also, to be precise. So you have reported an experiment in a paper, but the reviewer asked you to half the error bar in a measurement. What will you do to satisfy the reviewer? Okay. Can anybody explain why? Okay. Somebody answered D. So why so?
So always there has been a error when we take the samples. So that's why I said we try to eliminate those errors whenever we
But
find the error.
like, how will you try to half it using a systematic error? Look, a systematic error means, like, what do you mean by systematic error?
Systematic error that we mean when we calculate the standard error.
Hmm?
I think standard error that will be equivalent to systematic error.
Actually, systematic error is something like you have an experiment, and systematic error is something that is the error that is very consistent with each of your experiment, like observations. That is what is a systematic error. So there are two kinds of error: random error and systematic error. Systematic error will have, like, because of some faulty equipment. So in each of the observations, you will see that error. Okay, that's what is systematic error. I don't know. Your voice is kind of breaking in between.
Yeah, got it, sir. Thank you.
Ah,
Thank you.
okay, okay. So the C option that somebody was telling, that I will redraw the picture with error bars half the previous size. It is something that is quite unethical. So yeah. So error bars is something that we are, whatever we are getting, and we report it that way. That's what it is. We can't half it actually. So option B, anybody would like to explain why two persons have told it? So how is it? Why it is B? Anybody? No? Okay. So let's tell it as standard error 1. Okay, so we know that we can take sigma and root and 1. So this is the first condition. Okay, that's simple. Yeah, the lesser the error, correct. So, and this is SE2 equal to sigma root n2. So these are the two conditions. This is a sigma, the one before review, that the standard error, and this is the second one. And it is given that standard error to do the 4 times. So it is given that that we have to half the error bar. Yeah, so standard error 2 is kind of double of standard error 1. So it is given in the question. These are this is given, and this is something we are solving it. So if we kind of divide both the equations 1 and 2, so what we will get is we will get it like root n2 into SE1 by root n1 into SE1. So I have cross multiplied and sigma and sigma. So the population won't, the standard deviation population will be same. So cut it. Now we will put in place of SE1, we will put 2 SE2. So root n2 into SE2 root n1 into 2 SE 2 SE2. Okay. So we will see that SE2 SE2 can cut, and root n2 by n1 equal to 2, or n2 by n1 should be 4. Okay, so we have to take 4 times the number of readings to basically get half the standard error. Yeah, it makes sense. Yeah. So yeah, I was telling about maybe a kind of a pharmaceutical example. Yeah. So here you don't have to calculate the standard deviation. Hello? Yeah. Yeah. Krishna, you want to tell?
Yeah. Can you go to the previous problem?
Sure.
Previous problem.
Mm-hmm.
Sorry, I missed that. So I just wanted to show what explanation you have given.
Okay, sure. You want me to explain again, or?
In short, if you can explain it, just to
Okay.
take others.
So yeah, sure. So there are two conditions. So first is which we have standard error that is kind of double, and the reviewer basically tells you to essentially half the standard error. So what should you do? So standard error 1, the one conditions are like before, and the 2 is the final one. So basically I have taken, and this is something that is given in the question. The standard error 1 is equal to double of standard error 2. Okay. So basically yeah, it is written, yeah, that but the reviewer asked you to half the error bar. Okay. So and then so basically I have divided these two equations and then substituted this value. Okay, then I am then that's only the calculation. Then I am saying that the n2 divided by n1. I am saying that you have to take the 4 times the value of it. That's what it
So
is.
it has to be done in this manner only, or because I understood it as a theoretical question.
Yeah.
Wherein,
See, if there
you
are
got an
like
error. You
theoretical
got an
question.
error, or yeah, sorry.
So if the question is telling like theoretically you can answer essentially because the options are like kind of made like that. But if the question comes if it comes like all the questions are like 4 times here it is written, then some place it is like 8, 2, 3, 6, 4. Then numerically also you have to solve it. Yeah.
Yeah, correct. That's the reason you have assessed in this manner.
Yeah.
Okay, got it. Thank you.
Sure.
Thank you.
Sure. So here you don't have to calculate the uh, uh, don't have to calculate the mean, the standard deviation, everything is given. So yeah, only the interval estimate you have to calculate. So kind of a easy job now. So somebody is asking why we need to halve the error. So as I told, yeah, it's all about the precision. If you have more number of samples, the precision, the reliability of data increases. So if there is very large error, then it's very unlikely the data is less reliable. So if you are halving the error, then you are increasing the reliability like 2 times. Yeah, that's what it is. Because this session was more on numericals, I don't think so we will get more time on discussion, but yeah. Because the numericals take a bit more time than solving.
Sir, but in the final examination, it will be very difficult to answer the questions. It's such a lengthy questions are asked.
Mm?
In the final examination,
Uh-huh.
it is very difficult to answer the questions because if such about the many questions they are asked, and then it is difficult to answer the question with the stipulated time. The time limit is there, will be there, है ना?
Yeah, time limit, yeah. Yeah.
Because then because they are not going to ask the simple questions, and every questions where we have to calculate the mean and then the standard error and the standard deviation, and then will come to the final conclusion.
It depends. Some questions won't have this
But
like.
how much percentage of questions will be numerical? There might be some percent only, on the like
I am.
out of maybe say 50, how much 10% or 5% like that it will be.
No, it's not like that, but they will be having a weightage on this numerical questions. They will concentrate on these numerical questions. I think they will ask.
Just like in assessment 7, they have given one question and 6 sub question of it.
Yeah,
Eight
yeah.
weight, weight carrying of 0.5 marks. It's almost 3 or 4 marks is there only.
Yeah.
No,
So yeah,
they
depending
will.
on the time, they will decide the number actually. Yeah.
No,
And
but I am saying the
Mhm.
entire paper, there
No,
might
no,
be
they won't have
something
only the
fixed, no?
remedies. Yeah, please.
Sorry.
Sorry, I objected.
The paper is of, I think, 3 hours.
Mhm.
And 10 or 15 questions are there, or which 2 to 4 questions are of numericals.
True, yeah. Possible. It is
Now,
possible.
now see the assignment number 6 and then this following is 7 number. There are a lot of numerical questions they have asked.
Mm-mm.
No, that is
Um,
entirely on that assignment, no? So it is only
yeah,
numerical in that assignment.
yeah, that's what I'm saying. So 6th onwards, you'll be having these questions on the numerical. So you can guess that in the final examination, there might be some 30-40% on the numerical because their main concentration will be on the numerical type of the question, not the theory.
Don't know. Sir can tell us. We might
Yeah,
know.
I also don't know. Like whatever goes on in the background of question, like setting the question paper, that we
Yeah.
are actually not involved in.
But yeah. But if you can speak to the tutor, we'll get to know like how much percentage, because definitely all the papers like of RM are fixed on this. So I just asked.
Mm-mm. Yeah,
And I'm not going to tell you how much will be the percentage
yeah.
also.
No, but RM usually RM is not only for one stream. No, that is
Yeah,
for
yeah.
all. So that is why
But
everybody
statistics is
doesn't
something
know.
that is like most of the like I don't know about the other things, but statistics is something that is
Not very
universal for. But
commonly taught, because
yeah, but it is kind of universal and it is kind of applicable to a lot of areas, and I think universal to all, actually universal to all the sciences. I'm not aware of the other fields, but yeah.
That it may be
correct. It is
universal, but it is
universal.
not a common
It
thing.
is
When
it is
taking,
universal.
I
That
go to search some statistician, I would hardly find 1 or 2 in the locality.
Maybe down the research you will maybe like down the track, these things will maybe come up. Maybe not. It is not looking relevant now, but yeah, it will.
no, that is relevant only because
Mm.
analyzing any data
Yeah.
or numbers, anything which is numerical, anything which is descriptive, also which is turned into numerical, and then we can use these kind of probabilities there.
Yeah. So at that time it shouldn't look alien. That's the motive here,
Yeah,
because
that doesn't look alien,
this is
but
not a
assessing
statistics
that
course.
using these
That's good.
formulas, it
It is not a
becomes
statistics course. You will like during my coursework in PhD, I took, so I had this intro to research kind of a course, and then I took another course for, like, I am from biomedical engineering, so I took another course that is statistics for biomedical engineers. So essentially that is totally kind of full on statistics. So
Okay.
yeah.
Means even
Uh,
after this paper, I have to go search for statistical tuitions or some additional course.
no. It won't. I think so. The questions more or less will be of this level only.
No, it's okay, sir. But the matter is, कि after when I saw the 7th question paper, assessment 7,
Mm-hmm.
means especially that x plus y is equals to dash a plus minus dash b. Those types of questions, they are just मैं पूरा दिमाग लगा लिया सर, पर वो कहीं पे भी किसी एंगल से मेरे समझ में नहीं आया.
Okay, maybe
आज
yeah. Once we discuss that once, maybe I can simplify much more.
no. But
सर वो
then what
डिस्कशन तो
happens?
सर पेपर के बाद करोगे, तो अभी तो
Yeah.
पेपर तो 3 दिन में सबमिट
हाँ,
करना
यही
है.
होता है कि असाइनमेंट में मार्क्स नहीं मिलते, तो later we
Maybe.
understand the concept and we are
Sir,
able to do
previous in
that.
some papers there were multiple choice questions,
Mm-hmm.
जिसमें से आपको 2-3 सिलेक्ट करने थे. अब आई वाज इनटू प्रिंस कि भैया कोई एक ही सिलेक्ट करना है, या बी, सी या डी. So I selected one and 9.033 marks.
Yeah.
Sorry, 0.33 marks. And मेरा पूरा वेटेज अच्छा खासा होने के बाद वो पूरा नीचे आ गया, यानी हार्डली 3 या 4 मार्क्स में नहीं हुए. अगर बचे हुए पूरे असेसमेंट के पेपर्स स्टैटिस्टिक्स के ऊपर ही रहेंगे, तो आई एम श्योर मुझे फिर से ये पेपर देना पड़ेगा किसी दिन में.
No, no, don't worry like that. But yeah, the all
No,
efforts are
even
towards.
same here. You are not the only
Everybody is
person.
traveling on the same boat. सब मास्टर
Yeah,
डिग्री
I,
पास
I
करके
literally,
PhD
you
के लिए
at
बैठे
least
हुए
got
हैं.
3 to 4. I got 2 only in that assignment.
Like yeah, like hoping in the final one, I think you all will do good. I think
सर ये
So
that's
बार
seventh one,
फाइनल
I
तक
am so
पहुंचेंगे क्या?
fearful of attempting that.
no, no. The questions will be less, and the questions won't be harder than this. That's what I expect. Like I don't know.
इट इज समथिंग दैट मिलिट्री ट्रेनिंग की पहले आपकी ट्रेनिंग कर दी जा रही है ताकि मैदान जंग में आपकी तकलीफ ना हो.
पता नहीं वो
But as far as but the assignment is concerned, why don't we discuss the concept first? That is to be clear first before solving the assignment.
actually
Because
it is
because
correct.
what we are doing
Mhm.
video lectures we are listening and it's all okay. That is all the theoretical because even that mathematical numerical problem they are solved in terms of language that way anybody cannot understand. So
Okay.
before going in for the assignment, we should clear all this
Theoretical aspects,
concept. Yeah.
Yeah. No, correct. I also, sir, actually, rather considering the problem.
When we appear for the examination, so we should get it prepared. No? Then we appear for the examination. It's not like that, that we are appearing for the examination, then getting the explanation for what was the formula and
Yeah.
now
So
you-
And
that's
actually, we
basically
don't,
the.
answer, we don't have like that, like before and after. Some exams, they will have before the assignment something and after the assignment something. So here it is not like that. Whatever assignment we attempt, it is the final thing, and
Final
we
thing,
usually get explanations from you or other tutors who comes on the
then,
platform
but
later.
The thing is, we
when
are
we
actually
start the
bound
assignment, then we are
from
we are able to
NPTEL.
get the explanation. Na?
Yeah.
In the
thing is,
last
we
two
are.
lectures, we got it clear because so many formulas, like the
Yeah,
standard
yeah,
error,
we
the
got
solution, they
clear,
were
we
explained.
got the clarity in the last 2 lecture
Yes,
only.
that's all. But while you are going through this video lecture, then you won't get that much sort of I mean clarity.
No. Actually, I was completely blank after attending that week. Even week 2 was tough for us. So
Mhm.
week 2, then week this 4, I think the 5, and then now, 6, and now 7 also is tough for because it is mostly
Kind of a
numerical.
numerical, yeah.
Yeah. Second was that Venn diagrams. So that also we were not that aware, which was taken later. So we understood the concept later, that motor stolen and other things, how you have to apply. So basically the application, we are understanding it later.
Later,
We are
yeah.
not expecting the problems, but we are expecting the explanation to be given before the assignment.
Yeah,
So that you can speak to
that is
sir.
that is
Actually,
You can
this.
speak to sir and then cover.
Yeah, actually,
questions are
the
not that
timelines
much
are
difficult.
given by NPTEL. So
Yeah,
that
I
is.
understand. I understand,
We
but the
don't have
questions
any
now
issue.
need not be covered.
Yeah. We,
But
yeah, we.
explanations can be covered, no? Because sir has also given the explanation only,
True,
but we
true,
are
true.
not understanding that way. But when you guys present it in a simpler form, then we get it very clearly. So what I understand is, if the explanations are given before, it is great. Though not assignments or any
Whatever
questions.
you taught, that was more practical than what was taught in the video lecture.
Got it. It
That's
is
what
like yeah, like those are kind of different things. Yeah, like
I
we taught.
absolutely agree on that point, sir.
yeah.
Because sometime on the lecture it's like someone is telling us a story and we are just listening to it without understanding what's in there in the lecture.
Actually, the application perspective is not very
Yeah.
clear there.
Yes.
Sir, that is the
And
problem.
even in the
If we
numerical
get
some other things I
application,
have seen.
if there only, as I said last time, if there only he explains 2 or 3 examples over there of
Yeah.
any question, we are understanding that okay, it is. He has given some kind of random theorems kind of thing. So we understand it as a theorem only rather than the problems.
Okay. Maybe we can discuss that. Yeah, there are two
Serious,
things
I think that is
we
the
can't.
biggest problem people are
It's
not
like
getting.
it's like there are two things we can't. So professor, the way professor teaches is we can't reach it in any way. But the thing is, yeah, the whatever time the NPTEL lectures are also very condensed, so they can't like take it up everything. They also have foundations like we have. what to discuss and
Yeah,
what
Yeah,
to
yeah,
do.
correct,
normal.
correct. Understand.
Normal.
Understand.
All respect and regard to all these stuff. They are that
Yeah.
And
presentation also.
sometimes it feels that he's just reading some paper and telling us.
Okay, maybe we
But that's
can, this
okay.
discussion
That's
will go
okay.
on
That is
actually.
his way
Yeah.
of teaching. But this
Yeah.
is our feedback, wherein
Yeah.
we
Yeah.
understand that
Got
it
it.
is more of a theoretical thing.
Got it. Got
And
it.
later, when we got this assignment, actually, we were not able to attempt because
Yeah.
we couldn't connect many of
There
the
is a
things
gap
over there.
actually. Yeah. You feel
Yeah,
so.
there's a big gap, and now in the seventh assignment also, like there are a lot of t-test, hypothesis, and other things which he has told. That's too theoretical, but when it comes to practicality, we are only able to get it from these sessions in the terms of applications. So that is what we are telling. At least the concept, if you explain, it becomes very easy for us.
Okay.
Also, sir,
So
can
before
you
that,
take
actually, I have to
Some
ask NPTL. I can't.
before we going for solving this assignment 7 because it's too difficult.
True.
It is difficult than assignment number 6, and I think the more assignments to come, that will become more and more difficult.
sir, can you
No,
take
no.
some points of assessment 7?
Uh,
Just give the
I
hint.
know
Just
it's
give the hint.
not a thing to say.
I don't know
असेसमेंट
because
7 का वो जो x प्लस y वाला जो फंडा था,
like I am not. I don't know the NPTEL. Basically the active assignments is something that I don't know we should discuss or not. So yeah, like
okay, okay,
from
okay.
next time I will ask them if they are okay with it. I have no issues discussing.
And इस बार
Anyway.
के मार्क्स कटने बाद ही अगली बार
Yeah.
मार्क्स कमा पाएंगे. Okay,
Got it,
that's
but
all.
yeah, like we also have some kind of foundations. Sorry.
No, no.
Foundations, yeah.
So equally, no. You can ask him in terms of the concept, not sharing the assignment. That is what we
No,
are
no, it's not about
talking.
this. ये means I tell you उसमें x plus y दिया हुआ है, फिर एक मिनट, I will get the paper. Just give me a sec.
No, no. I understand what you are saying. I too couldn't understand that.
Means I was just blank. I asked one of my mathematician friend कि what is this? So he asked in return कि भैया ये क्या उठा लाया बोले थे.
Okay,
अरे यार मुझे नहीं
yeah,
पता
yeah.
तुम्हारे मैथ.
Just to object, kind of sorry. Like, can we focus on this question also?
Oh, sure, sure, sure.
Please, please. Yeah.
Extremely sorry. We
Yeah.
got diverted from the point.
Yeah, yeah,
Let's,
yeah. Sorry.
yeah.
Yeah, the concerns are real. We will look to it. Sorry, if things are
Sorry,
bad.
continue, please.
Yeah, please. So actually we are running out of. I have prepared around 10 questions, but I think so it will not be enough. But yeah, okay. No issue.
Sir, can you explain the how do we calculate this 95%, 90%?
Uh-huh.
Is that
Yeah.
yesterday you
Sure.
Just
explained?
give
Actually,
a shortcut and
yeah,
we
the
will
thing is,
proceed.
so as there is no time to like solve it and wait, I have the solution here. I will just show
Yeah.
it and then explain it directly.
Sure, sure.
Yes, sure.
So, so this is the x. So x. Here we have sample mean as 20, and then we have the population standard deviation as 3, and the sample random sample of 64, the root n. So we are getting new around 20 plus minus z into 3 into 8. So now we have to find the different confidence level. So we have got this equation, yeah. From this equations, now we have to add the different z values. So 90% will have different z value, and then 95% will have different z value, and 99% will have different z value. So it's like you see in the z table, find 0.9. Yeah, you can find it, and then you can write the z value here. So upon that we can get whatever the range it is from lying.
Everybody please take a screenshot of this one. You can calculate it later.
Yeah. And anyway the slides will be there actually, so it's not an issue. I'll upload it
Where,
by
sir?
today. Huh?
कहाँ पे रहेंगे स्लाइड्स?
The slides are stitched with the module of the NPTEL that lecture module. I think in the down you have something called as problem solving sessions. So all our
ओके
sessions are
करेक्ट.
getting recorded, and I will be putting it in YouTube. So any of you guys want to rewatch it, you can rewatch it,
Yeah,
and
Yeah,
also
yeah.
yesterday session you have it has been uploaded. Any idea?
I don't know. I
You
don't
have
know.
only taken, right?
No, I take only
Hmm.
Sunday session actually. And the last Sunday session I didn't take because I was traveling to Norway actually.
Okay, okay, okay,
So yeah.
okay. Uh, okay, fine. Thank you.
Let's move forward. Yeah.
Yeah. So this is another question. Just take 2 minutes to understand, and I will show the answer. You can do it on your own, right? Once you get the explanation. And then, if you have any doubts, you can ask it in the next session, or you can mail me. It's not an issue. So as the questions are prepared, and so I wanted to give it just to you, and because otherwise it gets wasted. Okay. So these are the given ones, that x minus nu, the plus minus 3. Okay, and z, I have given that in 98% confidence interval it is z equal to 2.33, and sigma it is given as 9. Then we calculate the z. Okay, and then from n, so we have to find the sample size of the sample, so that's how we get the size of the sample. Yeah, so just the formula, nothing else. uh, okay, then it is telling if the precision is to be double, then the x minus nu should be halved, that we were getting it, yeah, in one of the theoretical questions that we saw. So this plus minus 3 is halved to 1.5, and we are getting n is equal to 195. Okay. Okay. If it is getting too fast, then you can slow it down, no issue. Just yeah, I think it is. We have written it properly there. I think it will not be an issue. But if any, then you can ask. So researcher found that the length of times for 5% groups to reach consensus on a policy has a normal distribution. So I thought there are some people who are from humanities also. So I thought, okay, let's put some such type of questions maybe. Yeah. So it mean 2.2 hours. Standard deviation 0.25 hours. So what is the probability that a randomly selected group will reach consensus in less than 1.5 hours? So we have the mean, we have the standard deviation, and we have the z we want to see. So we calculate the z, which is minus 2.8. So the area of standard normal curve is 0.4974. So the probability that a randomly selected group will reach consensus in less than 1.5 hours is 0.5 minus 0.49.
0.25 is what is the formula here we have used? Z equal to
Z equal to standard error. So
standard error. Okay.
so it's kind of a similar question, yeah. Just have to find the interval estimate. So I think this was the last one, and thank you. The things is, we will look it up, the other things that you discussed. So because of lack of time, I just had to race it around, but yeah. Yeah, so yeah, and
Can we get your email ID, sir?